So we're going to jump around a little bit today and talk about line graphs. I thought it was appropriate because you're probably seeing a lot of graphs and charts and things on the news if you've been paying attention to what's been going on with this virus. So how to make it, how to interpret them, looking at trends, I thought would be a really good thing to talk about. And then we can go back and finish up the rest of the chapter in the coming days. So if you're following along in your textbook, I'm going to start on page 902 today. And we're going to talk about line graphs. The other day we talked about line plots. Those were the things with the X's and the number line. This is the graph that you're used to seeing. You probably learned to make these when you were younger. They're used very widely when people report information. The one thing that you have to understand is that line graphs show change over time. So what we talked about yesterday with the categories, so for example, what is your favorite cereal? That could not be graphed in a line graph because there's no change over time. If I ask the question once and I only get one answer from each person, that's not change. The other thing is that you usually need to have some kind of number. You can't really do this with categories because it's kind of hard to show change with a category. You show change with a number. So if I was to ask you a question today, what's the weather outside? What's the high temperature? That can't be done in a line graph because it hasn't changed. But I ask you today, and I ask you tomorrow, and I ask you the next day, and I ask you 3 weeks from now, that could be graphed with a line graph because it shows change over time. All right, some other things that you have to consider. We talked about this yesterday. Every good graph is going to have tails. It's going to have a title to tell us generally what it's about. You're going to pick the axes, the side to side, or the up and down, which ones go where. The interval, what you're going to count by, how big your graph is going to be spread out. You're going to put labels so we know what everything stands for. And then the scale, what part of the number line you're choosing to show. So when I come down here and look at this example, okay, we've got a title. We've decided to put our year on the bottom. Time will always go this way. You'll never have time. I can't say never. 99% of the time will go on the bottom. You'll never have it go up and down. The y-axis over here is the population, and we've labeled it in million. So it's not just 1,000, it's 1,000 million. Let that one sink in. We've decided here to count by 50 years. Each line represents a 50-year time span. Going up the side, our interval is counting by 1,000. The scale we've chosen to show from 0 to 10,000. We don't skip any numbers. This little mark right here is called a broken axis. Sometimes you'll see it like this, where there's literally a piece of the axis missing. That means this dot right here at the end would be our 0 point in both directions. Since the next line that they've labeled is 1750, what happened to all those years in between? Well, I didn't write them out, but I can't just forget them. So they've put this little heartbeat or this little spacer in here to show that we've kind of chopped out 1,700 years of time. But then notice here, we've got everything counting by the same interval. We've got 50 years in between. So you'll sometimes see it here, or you'll sometimes see it here if there's unused numbers that you don't want to waste paper on and chop them out. You can only ever have one broken axis on an axis. So I couldn't do one here and then do a second one over here to show that there was a gap. That would be considered a misleading graph, and I would be very, very cautious about using the data. Same thing here. I couldn't do one at the bottom and then jump up and do another one up here. That would be very misleading. So we've taken the information here, the year. We would go over to 1750 and then up to 790. Now, 790 isn't on our list, so we're going to make an estimate. It's a little bit less than 1,000, just before that line. 1800 goes to 980. So you can see it's a little bit higher. I probably would have dropped this down a little bit more. That looks to me like it's on the line. It's close to 1,000, but it's not exactly. 1850 was 1,260. So 1850, just a little bit above. And you can see that we continue to graph them off of our chart here. Now, if you were asked to describe what this graph is, we talk about things called trends. You would say generally the population increased. There was never a time when it dipped. It never went backwards. It was increasing this entire time. You might use words like it increased dramatically, it increased sharply, steeply, quickly, towards the end, where in the beginning it was a very slow increase or minor increase. All right, so let's practice making one of these. If we shift to the bottom of the page, They've given us a data chart. I don't know if I can get this all on here at once. Let's see. There we go. Okay. So they've given us some data talking about the number of building permits filed in a major city, people who are doing renovations or they're putting an addition on or a deck or something like that. Each of the years and then the number filed. Now, the book has given us a graph already set up. If you were doing this with just a plain piece of graph paper, you would have to look at the numbers and say, well, I got to get from 2009 to 2014, what will fit on my paper? And I need to get from about 5,900, about 5,000, up to a high of about 16,000. What can I count by to make sure that I can fit it all on my graph? Lucky us, though, it's already set up for us. All right, so 2009, I'm going to come over, go up to 16,000. Lucky us, it's right on the lines. 2010, 15,500. Now, this is where it gets a little bit tricky. 15,000 would be halfway in between these. So 15,500 would be a little bit more, kind of closer to the 16,000, but not quite. Then 2011, we go to 13,900, just below the line. 2012 goes to 11,000, halfway in between. 2013 is 8,200, so slightly above that line. And then 2014 was 5,900, so just below the line here. Okay, now you can connect these to give some idea. If you had to describe this, I would say that the number of building permits steadily decreased. Okay, it seemed like it was a pretty constant change. It wasn't, a little bit in the beginning where it was a little change and then it really dropped off. But once it started to drop, it stayed pretty much the same. Okay, it never went back up. It didn't level off and become a flat line. Okay, let's look at some other ones that are done for us and talk about how we can describe these. All right, so it looks like this is about the cost of tuition. We've got some years here, the cost in dollars up the side, and then I've got some information here. I would say it's been steadily increasing. It looks like it goes up by about the same amount each year. There's no flat spots to tell me that it stayed the same. It never dipped back down or decreased. What they asked us to do was make predictions. Now, was it actually these numbers? We're not sure. But you can make a prediction based on the information. It seems to be pretty steady. You can take your pencil, or you can take maybe the side of a piece of paper. This happens to be a Post-it note. And you can put it here and say, well, I think it's going to continue. And you just kind of make that line. And then that's a prediction. So if I had to say in the year 2020, my prediction for the cost of tuition at this school would have been about $12,000. Okay, they say 11,500. I would have said it probably would have hit the line because I like round numbers. It's an estimate. It's a prediction. All right, so when we come down here, we're talking about the height of a plant. A little bit of a slow start here, but then it seems like it rises consistently or steadily or about the same. So if we had to make a prediction for 7 weeks, I'm going to line up something nice and straight, and maybe like that. All right, it's not perfect. It's a prediction. But then I can go to my 7-week line. I'm going to say that my plant will be about 12 inches tall. Based on what I've seen here, it might stop growing and level off and only do a little bit more. It might get a really good sun and rain season and spike up. Maybe it grows a whole lot faster. We don't know. But based on what we've seen, the trend is that it would continue in that line.